Good afternoon, everyone, and thanks for joining us at the virtual portion of the Groundwater Open House today. My name is Laura Handley, and I am the Aggregate Industrial Minerals Geologist with the Ontario Geological Survey. Today's talk is going to focus on taking a slightly different approach to understanding and evaluating groundwater resources by adding added value provincial datasets such as our Aggregate Resources Inventory database. Although aggregate mapping assessment is largely geared towards land use planning purposes in Ontario, it could also serve as a useful source of information for geotechnical or groundwater work, in which we will take a look at in the next few slides. According to the Aggregate Resources Act, aggregate is defined as a gravel, sand, stone, limestone, dolostone, marble, or granite. Looking at the diagram on the right, you'll see that we virtually use aggregate for everything. From the house that we live in to the roads that we drive on, aggregate is at the forefront of it all. The industry is actually valued at a whopping $1.2 billion a year in Ontario. As the demand for aggregates increased and environmental concerns grew, more comprehensive resource assessments were necessary to understand the extent of aggregate deposits and the potential impact of extraction on local environments. In response to these initiatives, the OGS launched the Aggregate Resources Inventory Program, also known as ARIP, in the late 1970s, with the goal of identifying areas of potential aggregate resources throughout the province by characterizing both the quantity and quality of aggregates through a series of desktop work and field examinations to ensure adequate supply and protection for future use. Each ARIP is completed on a township scale and contains the same three deliverables. These are a 1 to 50,000 scale sand and gravel map, a 1 to 50,000 scale bedrock resources map, accompanied by a detailed report that further describes the ag quality and deposit information. The map in the middle shows our provincial ARIP coverage to date, with the eventual goal to cover the entire province. In an attempt to modernize our existing provincial aggregate data, the OGS launched the Aggregate Resources of Ontario compilation back in 2015. This was designed to streamline historical aggregate data that was previously published in various digital formats and datums. The goal of this exercise was to provide a single source for both sand and gravel as well as drift thickness mapping, and is intended to be updated as new geoscience data becomes available. So I just want to show you an example of the added value that the sand and gravel maps could provide. The figure on the left shows the superficial geology of a small area east of Peterborough, which describes the depositional environment and overall sediment texture at 1 meter depth, and the figure on the right shows an ARIP sand and gravel map of the same area. You'll see that the ARIP map further subdivides these superficial deposits, provides an assessment of thickness and percent gravel. Looking at the bedrock portion now, the figure on the left shows another area near Peterborough, overlain by Paleozoic geology of southern Ontario this time. As you can see, this map shows outcropping and subcropping geological formations. Again, the figure on the right shows the same area, but overlain by an ARIP bedrock map. As you can see, the ARIP drift thickness map shows the depth of bedrock information over the geological formations to get a better sense of how thick the sediment is over bedrock. Although aggregate mapping and assessment is largely geared for land use planning purposes, it is also a useful source of information for geotechnical or groundwater work. The added value that the ARIP maps provide could help bridge the gap in OGS datasets suitable for groundwater applications by providing more detailed information on surface and subsurface porous material. It could also help identify, delineate, and characterize shallow subsurface sand and gravel deposits, and it could further refine depth to bedrock maps in thin drift areas. Detailed information on subsurface material type, depth to bedrock, material composition, and aggregate quality are among some of the key data included in this compilation that could provide insights on suitable groundwater recharge areas. This aggregate approach fosters a more comprehensive understanding of resource availability that is essential for sustainable groundwater management practices. Thank you for your time today. If you have any questions or comments, please send them to the email you see on the screen. Thank you.